In this video, we are going to look at how to create a custom polycount and try-count debugging tool inside Blender viewport using Geometry Node from version 3.2. Before we dive in and create this node from scratch together, let's look at the final result, functionality, and benefits of this debugging tool we are creating today. Traditionally, to obtain accurate polycount for individual mesh objects, we first need to select said object, enter edit mode, and read the try counts at the bottom right hand corner in Blender's default scene statistic. This is quite handy, but it's not quite handy enough if we have a big scene and we are comparing multiple meshes side by side. Also, when we delve further into the procedural generation path, when we instance multiple mesh, then the polycount inside edit mode of the original geometry may not or usually does not represent the polycount of our final generated mesh. However, you can see that our debugging tool can still update automatically from the source mesh 900 something tries. After the procedural generation, it will spit out the accurate try counts. So without further ado, let's dive in. So starting from a blank Blender scene, let's construct the geometry node together. Firstly, I will put a Suzanne the monkey in the scene as our preview mesh. Then we can make a new workspace under General and Geometry Node. This is the default workspace that comes with Blender. So with our Suzanne selected, we can click New, and it will assign a new modifier using the same node graph we just generated. Let's rename it to GN try counter. GN stands for geometry node. Oh, my all caps are messed up. Let's do that again. Try counter. So this is the group input, geometry input. It is referring to the triangles, the vertex, the edges, and the faces when we enter edit mode. These faces, these edges, they are all represented in a list. And this is all the data coming out of this green dot. As default, it is going straight into the green dot output, so when we go back to object mode, it is outputting the same geometry. So we are gonna work magic and do any functionality we want in between these lines with a strings of specific nodes. So first of all, there is a node called domain size. Domain size can take it a platitude of different object type like instance, curve, point cloud, mesh, whatever. As long as we plug in a geometry, then we can read the point count or edge count or whatever. But you see, we can't really preview it because it's the wrong data type. This node can output geometry, which is the darker green dot. And these grayer green dots are numbers or values. They are not faces or triangles, so Blender cannot output them as a geometry. This is why we are seeing this red line error. What we need to do now is first convert the value into strings. What it does is that it is, instead of storing these as values or numbers, it is going to convert it to text as string. And sadly, string cannot be outputted at the same time either. So we're going to need another node called string to curve. Yeah, curve are the lines and the vertices that are geometry. Now we can preview it. So now that we can see there's 2012 points in this object. And how many faces you'll see? There's 1968 faces. However, this face is referring to, if we just double check it in edit mode, referring to the face count, which are quads, because this Suzanne the monkey is mostly constructed with 4-sided polygon, aka quads. What we are really interested in most circumstances is the try count, because either in film industry or game industry, rendering engine would always triangulate your mesh and draw out triangles instead of drawing out quads. It's just the way how graphics works. So instead of getting the face count 1900 something, what we really want is a triangulated version. So before we get the domain size, we need to first triangulate the mesh. And you see now, we are getting the accurate number, which is 3936. However, as someone told me in the past, the difference between mathematics and physics is units, right? If you're just given this 4-digit number without context, it's difficult to understand what's going on. So we are going to add a unit. And as we discussed before, unit is an abstract concept, it's a word that we humans understand. Blender doesn't understand the unit in context in geometry, no, like it is just using decimal place, right? There's a default unit and you don't need to input the unit. So for us, again here, unit is for human minds to process. So it is an idea, a word. So we put it in string. Our unit here is tries. And we can take the number and add the tries in the back of the number. Just put the unit after the number, right? So in order to do so, we're gonna search for a node called join strings and plug in first the number, then the unit. So now we get a comprehensive context for the number and the unit. For aesthetic reason, let's also fill the curve so that it is easier to read, right? If it's just some outline without filling, then it's not so easy to read. Afterwards, we need to display this number on top of the original geometry instead of, replacing the geometry. So just like what we did with the join text, we are gonna get a join geometry node. The concept is the same, but it is dealing with geometry instead of strings, instead of words. So in this case, we have achieved the first functionality, which is to display a number polycount on top of the mesh object. However, the size and the position is not so easy to read, or it's a bit unuser-friendly. So let's address that problem now. As we discussed, it would be convenient if we can always see the text in front of the mesh, slightly below the mesh, and in the center, in the horizontal axis, right? So we're gonna do that by taking advantage of a node called bounding box. For those of you who is unaware, bounding box is the concept common in different 3D software. Let me bring up the viewport display here. If I display the object by its bounding box, so this is the auto-generated bounding box by Blender. It will look at the smallest cube or stretched cube that can envelop whatever geometry. So instead of messing with this, we're gonna take the same concept and function and use it mathematically inside our node. So let's take our original mesh and we will obtain its bounding box. So just for preview, you see that this is exactly the bounding box we saw earlier. Okay. This bounding box as a cube is not very interesting to us because we're not gonna use that. However, it also outputs a min and max value. So again, if we look at the bounding box, as a bounding box, there's always 8 vertices, right? There's always 8 corners. So the min and max vector output is outputting the minimum vertex coordinate and the maximum vertex coordinate. what do I mean by the minimum and the maximum? It means if you compare the x, y, z location of individual vertices, the mean vector output represents the vertex with the smallest xyz coordinate. So it should be this one because it's like negative in the x, negative in the z, and it's negative in the y. So it has to be the smallest vertex, right? Well, like the vertex with the smallest coordinate values. And on the other hand, that one is in positive x, positive y, and positive z. So that's the biggest one. So essentially, mean is updating xyz coordinate of this vertex. Max is the xyz coordinate of that vertex. So if we have the xyz coordinate, we can then calculate and automatically obtain the best optimized position where we can spawn our text. So, as we mentioned, in terms of x value, which means the horizontal positioning of this text, we would like it to be in the middle. So, let's do some simple math by getting the average x coordinate. So, we first add them together, then divide it by 2. Then we get the average x coordinate. So let's combine x, y, z and plug our new x value into our combined x, y, z. And we can also take advantage of the string to curve node and align the text horizontally in the center, and vertically we'll align it to the top, like so. So you see the text is now indeed in the center of the mesh. We just need to mess with the y and the z. As we discussed, we want it to be at the bottom and slightly in front of the Suzanne, which means that's just the minimum y and z. So now that we have obtained the new coordinate, we need to actually move the text by using the transform node. So we're taking the string to curves. Yeah, might as well. Maybe I should put it there. Yeah, after filling phases. So we're gonna position it there. One more thing I want to do is to rotate the text by 45 degrees in the x-axis so that it's easier to read in more different camera point of views. So this concludes the functionality. If we are to make one more safe bet, is to create a realized instance node there. Because you don't really know what's the deal with whatever geometry inputs in the future. Maybe there's instancing or particles or duplicates, and those won't be counted accurately. What we need to do is realize those instances so they become geometry, then the counting can proceed. So let's go ahead and test this with a brand new object. Let's say we put an isosphere. Then what we need to do is go to geometry node. Go to modifiers tab, add a geometry node modifier, and pick our try counter. Now you see, it is working with the accurate try count. Let's count it there. Let's see 80, 80, and it's positioned automatically in an easily readable place. So yep, the bounding box, again, you see the text is smartly spawned right in front and right below in the middle of the bounding box. And feel free to grab this blend file in the Gumroad link I will put for free, so you guys can directly use it in the future or reference it if you have trouble following the video. Thanks. Stay tuned for more geometry node content. See you.